Welcome once again. This is the sixth video on alkyl halide. Remaining part of this topic is the nucleophilic substitution reaction. That is, this part is already discussed, but this is the types of the different types related with nucleophilic substitution reaction. That is, substituting agent are different depending upon that there are the many types are formed by this substitution reaction. So substitution by the hydroxylic group when treated with specific alkyl halide with aqueous potassium and silver oxide suspended in boiling water. Alkyl halides are hydrolyzed to form alcohols. Here the halogen is substituted by the nucleophile. So for example, ethyl iodide potassium hydroxide, it will ethyl alcohol. Then methyl bromide interact with the silver oxide hydroxide, and it will form the methyl alcohol as a product. Then second reaction, that is substitution by the alkyl group, that is the alkyl halide react with the sodium acetylide to form the higher alkynes. So sodium, for example, sodium alkynide interact with the alkyl halide, it will form the higher alkynes, that is methyl alkynine, and sodium acetylide is with propine as a product. So this reaction occurs SN2 mechanism with a primary alkyl halide and by the SN1 mechanism with a tertiary alkyl halide. Then substitution by the alkoxy group. Alkyl halide on treatment with the metal alkoxide produces ether, and this method is preparation of ether, often referred as the Williamson synthesis. So alkoxide, metal alkoxide is nothing but the reaction of Williamson synthesis. So sodium ethoxide interact with alkyl halide, which will give ethyl ether. Then modification of this method involves in the addition of alkyl halide with alcohol in the presence of dry silver oxide, and this method is known as a puride method of the alkylation and is quite useful in the sugar industry. So only there is change in this the alcohol and a silver oxide, and it will give diethyl ether. The next substitution by the thio group. So alkyl halide reacts with the ethanolic potassium hydroxide, ethanolic potassium hydrogen sulfide to forms the thiols. So it will easily give the thiol compound by this reaction. Then substitution by the thioether group. So thioether groups are produced when the alkyl halide react with the potassium sulfide or in a hot ethanolic solution of the sodium ethyl mercaptide, it will give the thioether compound. Then substitution by the amino group. So alkyl halide when treated with ethanolic ammonium undergo the pressure gives the primary amine, and there is a C2H5 Br, nothing but alkyl halide interact with ammonia, it will form the primary amine, but further addition of it will excess of the alkyl halide is used, then the reaction continues, it forms secondary, tertiary, finally the tetra alkyl ammonium halide compound, a quaternary ammonium salt. Then primary alkyl halide gives the good yield of the amide, secondary amide except isopropyl halide, and tertiary halide preferentially undergo the elimination from the alkene. So this is ammonia ethyl bromide, and it will finally give ethyl amine as a product. Then substitution by an ether group. So when alkyl halide is heated with the ethanolic solution of silver salt of the carboxylic alkyl acid, alkyl halide yield ester, so silver carboxylate, and it will form ethyl carboxylate and interact with alkyl halide in the presence of alcohol. There is silver acetate, and it will form methyl acetate under the interaction with the alkyl halide. Then substitution by the cyano or the cyano. cyano or isocyano group. When ethanolic potassium cyanide, an alkyl halide, gives the corresponding alkyl cyanide or nitrile as a cheap product along with the small amount of the alkyl isocyanide. This involved in the nucleophilic attack on the cyanide on this alkyl halide. So potassium cyanide, your alkyl halide, it will give methyl cyanide. So this reaction produced by the SN1 and SN2 mechanism. Cyanide is a ambident ion, that is there are the two sides of the reaction, so it becomes called as ambident ion and has the two nucleophilic sides, so it is called as ambident ion for the reaction. So therefore cyanide attack the positive carbon on the alkyl group. Either the through carbon forms first or nitrogen forms second. So this is the first form and second form, and to form the alkyl cyanide or alkyl isocyanide respectively, thus with alkali metal cyanide, and it is the form first that react with alkyl halide to give the alkyl cyanide as a major product. So it is a major product. Methyl cyanide or alkyl cyanide is formed by due to the derivatives formed in the form first. Then unlike the alkali metal cyanide, when which are ionic, silver cyanide is predominantly covalent and hence the reacts with the alkyl halide through form second to produce the alkyl isocyanide as a major product. So silver isocyanide derivative forms the final major isocyanide. Methyl isocyanide is a major product in this reaction, and like that method. Then alkyl cyanides are very useful synthetic reagents since they can be conveniently converted into acid, amide and amine. So this is a alkyl cyanide. Further reaction with the water, molecules of water, hydrogen in the presence of the particular reagent catalyst, that is the HCl, H2O2, that is peroxide, and lithium alkyl compound. It will form the acid, amine and paraamine compound. Then substitution by a nitrite or the nitrate group. The nitrite ion, like a cyanide ion in an ambident ion, that is having two sides. Its nucleophilic attack on alkyl halide can yield either an alkyl nitrite or the nitroalkane according as the attack on alkyl halide takes place through the oxygen or nitrogen. So there is a two sides are there, so it will form this ambident ion. So ion nature and ionic nature. So sodium interact with alkyl halide, it will form ethylene nitrite, and finally interact with another molecule of this alkyl halide, it will form the intermediate compound which contain the nitrite as an ion. So thus the sodium nitrite and potassium nitrate, alkyl nitrite are obtained, while the silver nitrate or nitroalkanes are the products in this final stage. Then substitution reaction with melanic and and acetoacetic esters. So in this case, sodium salt of melanic acetoesters react with alkyl halide to form alkyl substituted melanic acetic esters respectively, and this is a term can be converted into the variety of the organic compounds. It is a simple reaction. So it is all over nucleophilic substitution reaction summary with particular nucleophile hydroxy group, then thio group, alkoxy group. As like this, will get easily head about what type of the products are formed: an alcohol, thioethers, primary amine, an alkyne, and nitrile, as and so on. Then next is the elimination reaction. So alkyl halide on treatment with ethanolic potassium hydroxide are concentrated into the the alkenes, and this elimination reaction in which the hydrogen bromide is removed from an alkyl halide molecule is termed the dehydrohalogenation. So in propyl bromide, potassium hydroxide, it will use propylene as a byproduct. So this is elimination reaction in that elimination of this alkyl, elimination of this halide group takes place and formation of the double bond. Then reaction with metal. So last one from this particular reaction, that is reaction with metal or metallation reaction. So alkyl halide interact with number of metals to form the organometallic compound. For example, with the magnesium, so they react with the magnesium in either solution to form a Grignard's reagent. So methyl iodide, Mg in ether, that is magnesium, it will in the presence of ether it will be methyl magnesium iodide. So isobutyl bromide interact with magnesium in the presence of ether, it will is 2-butyl magnesium bromide. And next is with the lithium. So alkyl halide gives the lithium alkalis with an more reactive than that Grignard. So isopropyl bromide in the presence of lithium, it will give propylene ethylene compound. Then propyl ethylene compound. And next is with the sodium. So interact with the alkyl halide sodium, it is the N-butane, and interaction with this alkyl halide and sodium, it will form simple compound, that is alkane as a product. So all of these are the reactions